Okay, it's pretty much 1:30, and welcome back from lunch. Up next, we have probably, I would say, a personal bias, the most important panel of the whole event, something that is going to help the industry grow as a whole. Interoperability and open AR. And so we have a very distinguished group of panelists here that is going to be led by Christine Perey. So please.
Good afternoon, everybody. Thank you for coming. As Damon said, this is the most important topic, but I want to do a hat tip to Damon as well, because he's been a sponsor and a big advocate for the activities I'm going to talk to you about for the first part of this session. Over 3 years ago, 3.5 years ago, Damon made a presentation and said, "We've got all these problems to..." Oops. He said, "We've got all these problems. How are we going to resolve them?" And I'll show you what his proposal was and how we've gone from there. But I thought I'd start by giving you my definition of what open and interoperable AR is, because you might have come in here wondering that yourself and wanted to have a definition. Everybody likes better understand. I'm not showing up on the. Okay, thank you. And I'm going to start off with my definition, but during the discussion of this session, we're going to bat it around and try to make sense of it. All right? So let's start off with, I think of augmented reality as having kind of three phases or parts, right? There's the physical world, the reality. There's this phase during which we need to design and set up create the content and set up the publishing platforms so that we can output an experience. That experience then has to be delivered. So that's the third part, the experience delivery, detecting the context, making sure that everything is at the right place, the physical and the digital worlds intersecting. I think open and interoperable AR kind of consists of anything, person, place, or thing, anywhere, any use case, any digital assets published by any software publisher using perhaps the workflow for a magazine or the workflow for building a car or something else. And that be able to be consumed by any standard compliant or open or a product, a piece of software and hardware that reads an open data format. So that's my definition, and one I've been floating around for, I don't know, maybe 6 months or so. Before that, I said, we just don't talk about really what open interoperable AR. Let's assume it's a goal. We'll define what it is later. That was what I said after I said we're not going to define augmented reality either. These people be my witness. I actually stood in meetings and said that is off limits. We don't define what AR is. But every once in a while, just for fun, we do crack that one open. In March of this year, we conducted one of our meetings, and we had a session just dedicated to what is included, what's not included in AR. You've heard lots of this definitional problems over the last few hours and days. So to get to interoperable, and open augmented reality, there are lots of problems. These were the problems that I listed now in February 2010, and these were the ones that I saw to be pretty important clouds on the horizon. And the white cloud is what you get when the sun is about to shine. But I didn't go over those in a great amount of detail. You've been hearing about them in other sessions, but essentially a lot of it has to do with fragmentation, and we'll be coming back to that later. Some of it has to do with computational complexity. That was one of the early ones. You'll hear more about that from Neil. So the one that I thought needed to be worked on, I didn't see a lot of other people working on it, was these silos, the problem of having technology silos that didn't allow things to be content to be consumed from one platform to another. So this is now back in February 2010. I said, okay, suppose we were all in this boat together. We all want augmented reality to succeed and overcome those obstacles. Then we need to educate the market. And perhaps there'll be some company, one large company that'll organize, or maybe even a small company that'll provide some solution that's just a runaway success, and it's better than anything else. There might also be a small group of vendors or ecosystem segments that would get together and define something people could live with. Or we might have take on those challenges through some type of a centrally coordinated initiative. And that's what myself and the other people on this panel have been working on since then, pretty much. And I'm going to now step you through a few of those of the accomplishments that we've made. We're a grassroots community, several hundred people. We have a shared goal of open and interoperable AR content and experiences. There's a portal and some mailing lists, and about 3 times a year we get together in face-to-face meetings and hash it out. To do what? Our purpose is to accelerate the process by which barriers to that vision, that place in the future that we'd all like to live and where we have as a goal, the process by which those barriers are reduced. I mean, I think that's through a collaborative process, a lot of stakeholders. Well, where would you start? And Damon suggested, why don't we start with existing standards instead of this rubble over here on the right-hand side? And we thought there was just that was a really great idea. So the organizations that have been getting together on a regular basis have been growing. At first, I think my next slide is the tile diagram, and I'll build that up or not. But the important thing for you to take away from this slide is, yes, there's a lot of standards development organizations, and they represent membership. Sometimes those members are countries, sometimes they are companies. Sometimes they're, in our case, they're even individual members. Since we're a grassroots organization, there isn't a formal, really rigorously upheld member criteria. We're interested in people from anywhere in the world who just share a common goal. So these are the standards organizations that participate. In the middle, certainly Khronos, OGC, W3C, and Web3D were the first organizations that saw the benefit in having a neutral ground where they could start to compare what they have and compare what their members need and where the direction. And so the core group. And then we discovered that there were a lot of other standards that were relevant in other organizations, and those organizations have gradually been coming. Most recently, at our meeting last week, we had all of these except the ones on the left. We didn't have ISO represented in the Society of Information Display, did not come, and we didn't have anybody from OMA, but you've got to realize this is a phenomenal level of commitment on the part of these organizations that work on our behalf. They work on behalf of the members, but they work for everybody. And I also want to acknowledge the record breaker. Each organization has special areas that they focus on. The IEEE arrived most recently and announced that they have over 40 standards. That's what the number I was given a few weeks before the meeting. And when Mary Lynn came to speak, she said, oh, we found some more. Scratch that. Now we have 50 projects, ongoing, and standards that are already baked and proven, a variety of different things. So let's keep that in mind. We monitor the progress of these different standards development organizations. Really, we want to focus on where there's complementary work so that we don't get people reinventing the wheel. And we want to make sure that members of one organization are fully aware of what other organizations are doing, so we can identify gaps and work on those. And we also help them to coordinate. We've got several success stories, I'd say, that have been started by people who've come to our meetings and said, hey, why don't we get together and work on that? So these, when they find gaps in complementary work, we can coordinate. The standards community members, this grassroots organization, can provide inputs, and but not just to standards development organizations. We might provide inputs to vertical markets. We can provide our opinions, and then this is really valuable. People are very excited about it. We create resources that are available on the portal. Sort of this landscape, I call it, that picture with the hexagons, in order to understand how the different organizations complement one another. And a listing, and I mean a long list over the last 3.5 years, how those standards bodies have been increasing their activities or evolving their activities, the questions they have, the directions that they're asking for. We also work on a common vocabulary so that the different organizations can communicate from one to the other. And we have use cases, and this is often what drives standards, is you have to have a need and be able to articulate what the different actors are doing and how the problems can be resolved. So those are kind of the basics about the AR standards community, the work that we've been doing. We're going to continue doing that and fostering this as long as we need to. So that's what I wanted to start off with, set the background and the stage. Neil's going to follow now and tell you and tell us all about what the Khronos Group is doing. So Neil Trevett, president of the Khronos Group, thank you for coming.
Thanks, Christine. So Khronos has been going for around 10 years, but the last couple of years we have been eager participants in the Standards AR Standards Forum, the community, because we do find it's useful to get together with the other standards organizations that are out there. I thought I'd start by...
Just a second, you're not...
Oh,
okay.
Thank you. So I thought I'd start by asking what is a standard and why do we need them, and what is safe standardization, safe and responsible standardization. The standards are interoperability. They're interoperability specifications, so we can connect things together and create compelling end-user experiences whilst reducing the cost of making those systems or devices. And standards can be physical standards like USB, wireless standards like Wi-Fi, or software standards like APIs you would call to do 3D rendering like OpenGL. And Khronos is we have about 15 standards in progress right now, and we've had standards that have been successful. We've had standards that have been not successful, and it's interesting to try and figure out what makes a good standard that adds value to the industry. So these are like the top 3 lessons that we've learned so far. If it's possible to try and standardize stuff too soon. So if the industry is still in a Darwinian phase where we really don't know which way things are going to evolve and which way the market's going to grow, it doesn't make sense to try and standardize stuff before we know what actually works. It only makes sense to standardize something if the industry is pretty close to consensus as to what a certain type of interface should be. We definitely want to avoid design by committee. That normally doesn't work. But taking a close idea and that people have a good feeling that we can get to a consensus on what an interface should be and refine it by committee, that is actually super powerful, because we bring multiple perspectives and multiple industry players to make a proposal better. And the most important thing is that a successful standard, it sounds like you might be eliminating differentiation and competition in the industry because everyone has to do the same thing. But a successful standard, in my view, enables innovation and competition rather than stifling innovation. And we can talk more about that in the discussion. So this is one example of a bunch of interfaces. The gray arrows are interfaces, circling around application software. If you're an application developer, you're probably having to use internet standards for cloud services and 3D file formats for asset authoring and platform APIs that get down into the silicon. Khronos has a very specific focus area. We focus on the APIs for the application developer to get down into the silicon. And what are the APIs that we're most actively working on that are relevant to the AR community? We have the 3D APIs, OpenGLES and OpenGL. OpenGLES is the 3D API used on Android and iOS. It's pretty much on every mobile phone and tablet. OpenCL is for heterogeneous parallel computation. The new wave of APIs that we're working on are not to do with output graphics, but input sensor and camera processing. So we have OpenVX, it's a vision acceleration API. Stream Input is a sensor fusion API. And our newest working group that doesn't have a logo yet, it's so new, is the camera control API. And we're working to make these work together. Something that we'll talk about with Rob in the discussion is we're in the process of bringing those native APIs, they're all C APIs, and bringing them up into JavaScript so the web community can access compute and graphics. And then last but not least, the one standard that we have that's not a API, it's a file format, is Collada, a 3D XML-based asset interchange format. So I have like 2 minutes, so I'm going to go really fast and just give you like just a couple of insights into the newest of those APIs that you might not have come across before. OpenVX is the vision acceleration API. The challenge for vision in general on mobile and AR especially is we need a lot of vision processing, the feature tracking, but it's got to be at low power. And the existing APIs like OpenCL are very general purpose compute APIs, but it's going to be hard to drive the power down. You can leave your vision engine on all day without draining the battery. So OpenVX is an API that's in construction. We're expecting a draft spec at the end of the year that lets you create a graph of processing nodes. Each of those nodes can be in hardware if you wish, or DSPs or GPUs, depending on your architecture. And the graph it can be compiled down. If the implementer is smart enough, you can compile that entire graph into a single compiled node, so you can avoid memory round trips to memory, which is the thing that most kills your memory power bandwidth. The newest is the camera control API. So we have this quite a rich diversity of processing APIs. Once we have a frame from the camera, we can process it in the graphics APIs. They have shading languages that lets us do even vision and image processing. VX is specifically designed to process images. OpenCL is a general purpose compute API. We can process images there. But now we've kind of realized, perhaps a little late, that there's a gap and there's no really good API for controlling the mechanics of the camera and the sensor, the lens, the flash, and the sensor itself to generate a really good stream of images. If you're doing HDR, you want to vary the exposure in a burst. If you're doing depth extraction with focus, you want to do a burst of images with different focus points. There's just a bunch of different ways you want to use the camera, get back a lot of information about how the camera is operating. Are you in a bright environment, a dark environment? What's the distortion on the camera? You might want to process a region of interest in the image to save more processing bandwidth. There's no API out there. So literally 2 weeks ago, we announced a call for participation, and we actually had our first call this morning. We had like 45 people on the line. So there's strong interest in this camera working group. We're looking to create this camera control API as quickly as we can, and just in the nick of time, because using a single sensor on mobile is just the beginning of the mobile vision revolution. We're about to get multiple sensors, stereo players, planoptic arrays, depth cameras, which is essentially multiple sensors of various types scaled together, ganged together. A lot of processing is going to be needed, but we need to be able to get those images in a fast, efficient way and a flexible way out of the sensor to enable the advanced vision-based applications. So this is Martin's favorite diagram. So this shows how all these things kind of would fit together. We're working to create a hardware-accelerated platform, so every stage of an augmented reality flow can be accelerated on silicon without over-specifying. So we're just providing the building blocks. We're not specifying what vision and what SLAM you're using, but we're enabling you to accelerate SLAM, for example. The MEMS sensors, sensor fusion through stream input, the camera control API for the camera. We're defining timestamps, so we can timestamp every sensor sample from whatever sensor, be it the visual or the mechanical sensors, so we can at last figure out how they relate to each other in terms of time. We have EGL, which lets us route images around between the other APIs, VX for vision, ES for graphics, and CL for compute, and hopefully it all hangs together. So, and I mentioned at the beginning, we're beginning to take these native APIs and bring them up into JavaScript for the web community. We've already started doing that with WebGL. It's a JavaScript binding to OpenGLES. It's actually getting quite wide adoption now. At Google I/O a couple of weeks ago, Google announced that their mobile Chrome browser is now WebGL enabled, going to ship in a couple of weeks. A bunch of the other mobile browsers are there too. Microsoft, it looks like they're going to ship in IE 11. We have WebCL, which is in development, but getting close. Next quarter, we should see WebCL specifications, which is a binding to OpenCL for the Java community. And there's a bunch of other stuff we could do. These yellow blocks are the vision and the stream input, the sensor fusion and the camera control APIs. Really robust APIs that have been designed by the hardware community. I think there's a real good opportunity to raise them up into JavaScript. And W3C and Khronos are in discussions about how best we can do that. And Rob's helping in that process. My last thing, OpenCollider, is the asset interchange format. Not all of the tools out there have had really robust import-export, but we now have OpenCollider, which is an open source, really high quality importer-exporter. So anyone with a tool or wants to import Collider can now go to the website and integrate it in at no cost. There's conformance tests there too. And then last thing, GLTF, the transmission format. Collider is not a transmission format. You don't want to transmit your assets over the web with Collider. It's human readable, it's big. GLTF is a binary format designed to be almost instantly loadable into a WebGL application. Uses JSON for the node hierarchy and external blobs for assets and textures, so we can do streaming and compression on those in the future. And we have a Collider to GLTF converter that's in open source, already running pretty well. So you're welcome to go check it out. Okay.
So what I'm going to do is walk through our view of how web standards relate to augmented reality. I'll give you a bit of a sense of why I sort of bang on this like it's a hammer. I'll talk about where we think web standards fit in relation to AR, and then give a quick demo of some of them actually working at the moment. So we believe that AR is a great technology. But it's not really a full domain in itself. It's actually just a feature, a type of computing. And we think that the place that it fits best is in a flavor of the web, which is the next generation of the web, which is called the augmented web. And I'll talk about the different drivers that are changing that at the moment. So just to give you an idea of why I've got this sort of specific agenda. So we're the company that I run, the creators of BuildAR. So that was the first web-based AR CMS launched in 2009. And so I'm the chair of the W3C's Augmented Web Community Group and invited expert with ISO, W3C and the Khronos Group, and work with AR standards. And pimp for a book. So working on a book for getting started with WebRTC. And I'll talk specifically, I think WebRTC is really important for this. It's a totally different technology. A lot of people would think it's unrelated, but it actually unlocks a lot of things directly related to this. So just a background of where this sort of vision has come from. So in 2010, we showed the first model. This was at the first AR Standards Workshop in Seoul. And it's kind of hard to see. It's a pretty poor diagram looking back upon it. But pretty much all of this has come to fruition. So it just looked at the different layers. So from HTML, CSS, and JavaScript to the front, some presentation layers like SVG or WebGL, the video, and then layered back into the different sensors. And all of this has really pretty much come to fruition now. So we progressed with that view, and about early 2012, we were able to write a test harness. So it's a small demo site just to give people a sense so they could turn up with their device and see what is currently supported. Along the bottom, you'll see the 10 or so different capabilities that we test for. And this is really, this mixture of these 10 capabilities, I'm pretty sure it's 10, combined to create this whole new generation of the web. A lot of people will turn up with, say, an iPad, and they'll go, my iPad has, say, 3D, supports those sorts of things. What this really tests is the browser's access to those. So that is the key thing. All of these devices now have all of the sensors that you really need, all of the capabilities you need, but the bindings from the browser down to that level aren't necessarily available. And a lot of them are becoming available. So when we wrote this, no browser passed this test at all. And within about 4 months, we saw the first version, which was an Android device running Opera, and it actually passed all 10. And now it's quite possible the latest version of Chrome on an Android device, you can easily get to pass all of these. iOS devices, Apple are certainly behind the ball on WebGL and things like that. But I'll talk about that. Those sorts of things are developing very quickly. And so we rebuilt our whole platform about a year ago with this web-based framework. So now we have a consistent data model that we can use. It's all largely JavaScript-based, and we can now express this content out to the Geneo browser, native applications, or things that are running inside web browsers themselves. So that's the reason why we think this interoperability is really key. It allows you to have this consistent data model and express it in lots of different ways, and it just makes life so much easier than all of the silos of data that we were dealing with before that. And so I think this was presented at our meeting in Atlanta. Now I think it's really clear that all of these different technologies, so from fiducial markers down the bottom, geolocation, natural feature tracking, and SLAM, they've all evolved over the period since sort of 99, through from these dedicated platforms like desktop or robotics or game consoles, through onto the mobile platform, and then from the mobile platform into the broader web platform, either on desktop or mobile web devices. And it seems to us really clear now that there's a common trajectory. All of these technologies are now either working or in rough demonstrable mode on the web platform itself. And one of the things that is driving this in the largest way is a juggernaut called WebRTC. So if you haven't heard of WebRTC, basically it's about peer-to-peer communication. It's an initiative that was primarily driven by Google, but is supported by Firefox and Opera, and then Microsoft, and Microsoft also has a part to play in this. It's really focused on peer-to-peer communication, largely around video conferencing. It also does peer-to-peer data exchange. So you have low latency, really fast data exchange just between browsers. So you don't have to go off to a server and back again. You can establish a connection between two browsers and share things. But the thing that it's unlocked is access to the camera and the microphone, and then also allows the sharing of the sensor data really quickly. So now that Chrome and Firefox support it, they claim that 1 billion or over 1 billion devices or endpoints are now accessible via WebRTC. So this means all of these devices can then start to access these augmented web technologies. If you look at the sort of processing pipeline, this will be up on SlideShare so you can have a look at it in more detail. But at the moment, it's a pretty inefficient process. So you have to set up a video DOM element, access the camera, pipe the video stream into the video element, the camera stream to the video element, and then draw that into the canvas, and then from the canvas element get the buffer array or the typed array of the data, and then you loop around in a circle. So you've got the setup process and then a really tight iterating loop of just getting frames. And it's probably one of the least efficient image processing pipelines you could think of. And people, when they traditionally think of JavaScript in the browsers, they really think of slow, poorly performing implementations. And most people, the thought of doing natural feature tracking or computer vision inside a browser, they think it's, it's horrific. But even in this current implementation, it works. There are things that we can show that work right now, and I'll give you a couple of examples. From here, there's a whole lot of optimization that we're doing. So working with the Khronos group on how we can use things like an aspect of WebGL called GLSL. So we can probably access the GPUs and do these sorts of things in parallel. And JavaScript itself is pretty performant now and is being optimized as we go, being able to access multiple cores. We haven't even started really optimizing the language, and once we do that, I think that the sort of performance that we're going to get is going to be amazing. And this already works on mobile devices as well. It's not just desktop PCs. So let me give you a couple of examples. These are crude. They're not designed to be the flashy things. They're just meant to show you these basic processes working. And if you look at the basic positioning, I think we're probably about where augmented reality was in about 2010. So if you look at the sort of FLAR toolkit type demos that people were doing and the beginning of natural feature tracking, we're about there. But the thing is, it's accelerating really, really quickly. So it's going to happen much, much quicker than having to wait the 3 years to catch up to where we are now. So first, I'll show you a basic demo of. No, I don't want Wi-Fi. Thank you. So excuse the content of the person. So the lighting here is terrible. There you go. Okay. So yeah, you can see how flary it is with the lighting. But so this is basic fiducial marker tracking. It's a port of the AR toolkit developed by Billinghurst and Cato. The tracking is pretty good. If you excuse the lighting, yeah, thank you. You can. Oh, that's probably actually worse because I've got the backlit thing. A printed one probably would have worked better. But so I've just chucked a basic canvas element over the top of that. It's very easy to stick WebGL content. And so the tracking, if you forget the lighting, is actually pretty good. And that's just performing in a standard web browser. That's not straining at all. So that's the first example. The second example is fast feature detection. So in computer vision, the first step in natural feature tracking is often feature detection. And one of the most common algorithms for that is, let's get rid of that ugly guy and go to a different ugly guy, is the fast feature detection algorithm. So basically, you walk the rows and columns of the pixels and you walk a circle looking for patterns, and you try and work out if there's a corner there. Once you've extracted those features, then you can do things like turning them into vectors and doing object detection and tracking and things like that. So what this does is this just really shows you the first steps, the basic processing. And if you look at how many calls it's going through at the moment, so that's going through 500 to 1,000 calls through this detection process per second. Some of that, there's lots of optimization we can do, but a lot of that feature detection is pretty robust and it's performing pretty well. And then on top of that, we can layer WebGL and CSS-driven content very easily. So we've already got this stuff working in the browser. Now it's just a matter of optimizing it. And if you look at how inefficient that image processing pipeline is, it's amazing that we can do this already. So what's in the near future? So integrating WebRTC with Visual Search. So we've already got this sort of thing working with at Build.io we use the Kachum visual search engine. So being able to do that sort of dynamic visual search through mobile browsers and things like that, that works really well and it gives a pretty good experience. And that's the sort of thing we're also looking at using the Mirror API to integrate with Glass as well. So, you know, Glass is largely an Android device with a Chrome presentation layer, so it fits perfectly into that sort of experience. And Google's driving WebRTC, so it seems like a logical fit. The optimization of it, so it's not just these linear things on the main thread. You can now run threaded, effectively interfaces in the browser, so you have workers. So you can run these processes basically off the main thread, so the GUI itself doesn't lock up when you're processing these things. And then accessing the GPU and those sorts of things will optimize it even further. Then working with the Khronos group around OpenVX, and hopefully that'll surface up to WebVX, so we can get this sort of, you know, feature detection and all of basically the OpenCV standard processes, being able to access those in a silicon optimized layer is going to give us massive performance benefits. And then the camera access as well, being able to find the field of vision and control it really accurately. Those are key things for augmented reality. So yeah, there'll be lots more demos coming. I think SLAM is a really obvious fit for this sort of thing, with the sensor fusion that you can do through those you know, capabilities that are showing through the augmented web. So yeah, I think there'll be a lot coming really, really quickly over the next few months. And the thing is, these tools are there now. There's a large existing installed user base of these browsers, and people can develop it really quickly. There's probably the largest development community in the world are the JavaScript developers. So you will see the adoption of this happen virtually overnight. So yeah, I'd please ask you to join the W3C's Augmented Web Community Group. I think we're looking for people to do demonstrations, build use cases. Really, this is a way of getting us to reach out to all the different working groups. A lot of them are very siloed and focused on specific things. So just like the AR Standards Working Group, it's about reaching out and getting lots of people to talk across the different things that they're working on. Thank you.
All right. Third speaker in this panel. I'm Martin Lechner. I'm the CTO of Wikitude, and I'm also representing the ARML 2.0 standards working group within the OGC. I'm introducing you today to the Augmented Reality Markup Language 2.0, which has been drafted within the OGC, within the working group that I'm chairing. And in the next, couple of minutes only, I'm going to give you an overview about the language that we have defined. So first of all, I mean, when you talk about augmented reality, you all know, I don't have to tell you that augmented reality is a very diverse field. Many different technologies coming into consideration if you build augmented reality systems. So when you talk about standards, you have to somehow limit the scope to towards a type of augmented reality that you want to focus on. And so this is what we did when we got together. We were basically defining an augmented reality markup language for mobile visual AR. You know, there are tons of other AR types out there. So we are focusing on a mobile visual AR. Mobile means you're on a mobile device. Well, guess so. And visual AR means that we are focusing on camera as the input and output source of augmented reality application or augmented reality implementations. So basically, you know, something like sound-based AR is not something that we are actually considering. We're not ruling it out in the first version, but we're not considering it specifically. ARML 2.0 comes in two different shapes, basically, a descriptive format and scripting components. So very similar to the environment that the web is presenting with HTML and JavaScript, which also is a descriptive format and has scripting bindings with JavaScript. We also use the same concept. Basically, a developer is able to describe the augmented reality scene using the descriptive format. It's XML-based It's a XML serialization, but of course there could be other serializations like in JSON or whatsoever. So we actually define a generic object model and then define the serializations on top of that. So for now, it's an XML-based standard, and the scripting components, as within web pages, add interaction, basically, animations and all that kind of stuff, the same as you would do it on web pages with JavaScript. So we are reusing the same concept. And basically, I mean, ARML is based on other standards. So we are not reinventing the wheel for all the different, areas where augmented reality is actually tying into. Like, if you want to do some geospatial AR, there are already standards from the OGC. If you want to support 3D models, there are 3D formats like Collada, like Web3D, and other types of X3D, basically, or other formats. So we are really basing augmented reality markup language 2.0 on existing standards. A couple of facts on the markup language as such. It has been developed within the Open Geospatial Consortium, within the Augmented Reality 2.0 markup language standards working group. We have 53 participants as of today. We're still growing. We started off at the OGC meeting in Boulder in September 2011, have been able to publish a draft specification in November 2012, and ARML 2.0 is now published. It's an approved OGC candidate standard. There was a public commenting period where the entire community could comment on the existing draft specification. That has already been incorporated into the specification, and it's published in version 1.0.2. Submitting organizations are Wikitude, the Georgia Tech from Atlanta, the Cocky International, and the University of Alabama Huntsville. But again, as I said, I mean, these are just the submitting organizations. These are the ones which are actually have been mainly driving the initiative, and the other participants have actually been contributing to the specification as well. If I would have to summarize ARML in one slide, ARML 2.0, and basically that would be the summary of what we did. Because, reading through specifications can sometimes be tiresome, and so I was really trying to focus on the main parts. Well, basically, what you have in ARML is three main concepts. You have features, you have anchors, and you have assets. So let's run through the things. Let's run through these three concepts. The feature is the physical object that you are actually augmenting. This is the term feature is borrowed from another standard, from the geography markup language from the OGC, which basically describes a feature as an abstraction of a real-world phenomenon. So basically, a feature could be the Eiffel Tower in Paris. That's the physical object, and that's something you want to augment the Eiffel Tower in some way. So again, feature is the Eiffel Tower. The Eiffel Tower has anchors which locate these things in the real world. That might either be a geospatial location, like the Eiffel Tower in Paris, which is not the location as shown here on the map. But basically, it's just a pair of lat long and locates the Eiffel Tower, or something like that, something with coordinates. And another type of anchor might be something like a marker, which you're actually detecting in the video stream, or natural feature tracking, like an image that you want to track, something that is actually linking into the physical world, something that you can track. That's the anchor that you're describing. And the third part is the asset, or the visual asset, which is basically the representation of this particular virtual object in the 3D scene, in the augmented reality scene. So might either be a 3D model, might be an image, might be text, might be whatever. Basically, just the visual representation here. And as I said, we are focusing on mobile visual AR. Right now, we only define visual assets and not something like audio assets whatsoever. But we might extend that in the future. So what's next? Except for you to read through the specification, let us know what you think. It's out in version 1.0.2, as I already said. That's the link to the specification, but I encourage you to just type in Google ARML 2.0, because that's a lot shorter than this URL. You will find it. It's the very first link. It's currently being implemented in various applications and implementations, just like the Wikitude world browser and a couple of others. So it's active. Now we're in the process of getting implementations and really see the outcome of our effort over the last 2 years, approximately. The adoption vote within the OGC, so kind of getting the standard from the candidate standard to an adopted standard is scheduled for 2013. So after all these implementations have been coming out, there will be again a public commenting period. So if you are interested in that, if you are implementing ARML 2.0, let us know what you think. We are really, really interested in what the people think, because actually that's what drives the implementation of a standard and the specification of a standard. Okay, so that's what I had. Thank you very much. Now let's move over to questions, I guess.
Thank you. So, be happy to take a few questions from the audience, but we had some questions, and I had a question, the very opening remarks, or the very first few words that I said, which was I proposed a definition for open and interoperable AR that was very loose and conceptual. And I'd like to invite the people here, those who are first on the stage here with me, and then perhaps there are others in the audience who would like to discuss or could give feedback on the suggestion that open and interoperable is from the beginning about anything, anywhere, all the way to the end of any device and any software client that has the support for AR. Comments?
Comment from my end. Is that working? Yeah, perfect. All right. I don't see the slide now, so I'm trying to reiterate it in my head somehow. But I think we're going a little bit too broad now. We are talking about anything, anywhere, anytime. That's too much, I think, for interoperable AR, because it would be just like I don't know. You would say the entire GIS industry, for example, the GIS industry is interoperable. I mean, you have to define something. What are your use cases? What are you operating on? Yeah, exactly. So any use case, I think, is too broad because it could be anything. The entire world will be interoperable, and I think that's an illusion, I say.
Neil? I'm going to take the comments from the stage first.
I kind of agree. I think it goes back to the point I was saying that we have to make sure we're trying to standardize stuff that adds value, doesn't actually restrict people. And in the 3D domain, there's a good example. Vermal versus WebGL. Vermal tried to define one runtime, and it was way ahead of its time. We don't even know today what that runtime would be. And WebGL, which is much lower level, kind of just solving one little piece of the problem, which is how does JavaScript get to the GPU, enabled a tremendous swathe of innovation. And that we do want to standardize stuff, but we have to be very careful. If we standardize the wrong thing or try to standardize too much too quickly, we're actually going to slow things down.
Where do you see standards? I'm sorry. Okay, so at the end, there's a standard compliant AR-ready client.
Yeah, that sounds...
But can't we achieve interoperability in other ways than with standards?
Yeah, but it's that last point that is most worrying to me. That's like beginning to imply, perhaps, if we're not careful, that there's just one AR client, and that's... I don't think...
Any?
Yes,
okay.
Yes.
Different than one?
Yes.
Rob?
Yeah, I think there'd be some specific classes of AR browsers, because it's quite different. Magic Mirror implementation to a mobile AR browser, they're different. So yeah, if it was many use cases and then we define the specific ones, I think that makes sense.
Thank you. There was a comment from...
One of the things that I'm confused about, I downloaded several applications, AR applications here, and some of them refer to themselves as an AR browser, and some just have applications. And I'm unclear of what browser I can run all of these different. Do I need to have the specific AR browser, which I'm unclear on that concept, and then or will an AR application run on any of the browsers? I just don't know.
Okay,
And
probably.
I'm going to be producing content, so I need to understand that.
Probably I can take that on because I'm working with an augmented reality browser. Well, basically, I mean,
one of the ones I looked at.
yeah. So, I mean, basically, the difference between an application and an augmented reality browser, in my opinion at least, is that a browser has a content interface. So you can basically work with the browser. You are actually uploading content to a browser, whatever that might be, and you see the result in that browser. So you're experiencing some content. Other people might upload content. You can experience that. Versus in an application, there is usually some kind of a very, very restricted feature set, a very, very restricted use case, solving one particular problem. And that's not what a browser is intending to do. So I think that's the main distinction between those two.
Can I ask that we move over a little bit and expand that discussion to about HTML, the web, and people find a higher performance in many cases with a native application, although it's getting better.
Yep.
So please take that angle of it. And
because I think that's really where the metaphor came from our browsers, was like web browsers. So you could visit multiple websites. And so you look at we're really in the world where before the web there was AOL and eWorld and those sorts of things, specific silos with dedicated applications. That's pretty much where we are now.
So there's no interoperability
no.
on that.
No, they are currently separate silos, and that's something that we've really struggled with. Is creating content platforms. Most of our struggle is just with transformations from one to another. There's not massive differences really at the core. There's constantly moving and one after the other, but trying to get parity and then trying to just transform one thing to another is a very complex thing with a moving target. So at the moment, there isn't really interoperability, and I think that's why everyone's struggling so hard to get that sort of thing happening. I think ARML model is a really good abstraction.
Yeah, exactly. So that's exactly the point why we started the ARML 2.0 initiative, because we've seen that all the browsers which have been coming out, there are a bunch of them already, they all do support a similar feature set. I mean, it's not super equally clear, but it's somehow similar. So we found that we could, instead of all the browsers trying to define their own content format where the feature set is somehow the same, we could work towards a common format which everyone can adapt to. And then the content would run in multiple browsers. And then you would have a similar browser experience as in the web, because you could use Opera, Chrome, Firefox, whatever.
So if somebody created content on the Mateo authoring system, they can't run it on the Wikitude browser?
there you go.
So far, no. Yes.
And
exactly.
that's why the last part's so important, is being able to author on any platform and view on a variety of different client applications.
But in some ways, it's worse than that, because the biggest hurdle we as an industry have is the leap from a consumer knowing that there's some experience there and that they want to interact with, and then how to get to it. So you have to know which application, and then once you load it, you often have to know within that application where to go to get it, and then there's often, maybe one other step, and then you can get to the experience. And the fall-off rate at each of those is, sort of pretty high.
Catastrophic.
Yeah, catastrophic.
And there's a marker, and you don't know which one you're supposed to use to get.
Right.
Totally.
So I have a question for Martin. Did you think AR browsers are a short-term thing? I mean, and eventually browsers, as in web browsers, will become AR capable. Do you think that's where we're headed? So finding a piece of content associated with a mark will be as easy as Googling it on the web today?
Well, what I do believe in the long term is that AR will move into the web. So I'm perfectly with what Rob is saying here. Simply because people are used to using web browsers, they don't have to specifically look for something. It's in the web, so you can basically experience it with your web browser. You don't have to think about applications, and you don't have to think about I have to download an AR application just to do AR. It's actually in your browser. That's all you have to do is running the browser. So I would say like AR browsers and web browsers somehow merge and convert into one browser experience. So answering your question, it will be short-term in a way that at some point they will merge. Well, well, I mean, the time frame is when all of the big web browsers actually are capable of running all the APIs that Rob was mentioning. But I mean, we're getting there, and it's actually getting closer and closer. So,
and it's getting closer faster.
Yeah.
And the reason I think that will happen quite quickly is there's some other drivers like the video conferencing, web streaming stuff that's happening for its own initiative, its own reason. It's just a juggernaut out of control. But once you do that, you get all this other stuff as well.
Yeah, and I think that point will come when a few things need to come together, and all coming together from different directions. So there's the acceleration APIs, and to Christine's question, and once we get those APIs, and we're just doing a reasonable amount in JavaScript, not doing all of the feature extraction, but offloading that to the GPU in JavaScript, there's no reason why the performance shouldn't be pretty close to a native application. But then from the other direction, it's getting the content format sorted out, which is why ARML and similar stuff is important.
Other content formats as well, if you've got 3D models and other things like that. Okay, there's another question in the audience. Yes, please.
Yeah, so staying on the content, like the web really became successful when there was one location that you could. Yeah, sure. So staying on the content, the web really became successful with like Google or Bing or all those sorts of places you could go to one place, type in one thing, and know you'd be redirected to the person who could understand that content. With AR, if the Wikitude data set can identify 1,400 objects versus, Mateo's 1,500, whatever in their public data sets, like until we have, what can I recognize, what can I look up, what can I, do, what's the point of having a cross-platform content?
I think the point is that they will just be. So the way that we're doing it is, we publish out to Geneo and those sorts of things, but you can also then just add a script tag to your website. And so if somebody turns up with a browser that supports that, there's just some extra functionality available on the website. It says, there's local content around you, just like there are with Google Maps. You can see things around you, but you can then put it into a visual mode where you interact through the camera and that sort of thing. And I think people won't go, I'm searching for AR. They don't really care. They just want a useful experience. They'll rock up to a website. The website will show them some cooler stuff than other websites do, and they'll go, that's excellent. Like, it should be that easy.
They can also walk up to any person, place, or thing, and at some point have anticipate or expect an interaction that involves the physical and the digital world, so that they won't have to have specific calls to action with a little logo from a particular company saying download this and get that. There's a point not too far in the future, just like when you sit down at your browser, you're going to look for something, you initiate a search process. And there'll be a time when you look at something in the physical world and your sensors are scanning, and they'll tell you if there's something there that's of social nature or that is of interest to you based on the filters you've set up. That's if there's interoperability. That's if there is agreement at the semantic level for directories and catalogs that extend beyond the proprietary technology and silos.
So you imagine Google Chrome eventually having you have an image search tab and you eventually have a AR search tab and you use your sensors to...
You'd want not to be Chrome only, but every device is continually scanning. Damon.
So my question is, I guess, do you feel that it's going to be more of a push from the AR industry side for these standards for web-based AR, or do you think it's going to come from the other angle of web developers that want to kind of build these types of experiences because that kind of goes against a lot of the business models, right, of an AR company, is that, it's the whole walled garden approach again, right? As long as you're in my browser. So do you feel that may be the case that will help kind of drive these standards as more of these tools and people like yourself are able to do advocacy, that the web development community who's starting to spill into 3D and AR will be the ones that kind of really lead this charge?
If you go to
senses what, if it needs a separate browser, it just downloads it or whatever. You don't want to have to download multiple apps to get to the content, because that's the users trying to consume the content. Are you looking at ways to interoperate in that way where it's automatic?
Repeat not all of that question, if you can remember, but repeat the question, please.
The question was basically that there will be some kind of, I guess, link or URL or something. When you click on it, it will download the appropriate application, whatever you need.
Whatever you need.
Yeah, whatever you need for running this thing. I mean, that's already possible, in fact. What you can do is, for example, with Android, you can already supply a URL, and it will actually click on it, it will check if the application is actually available, and if not, it will download it from, or will actually take it to the Google Play Store and will let you download it. You probably want to want that. Because, I mean, is that interoperability? I would expect something like this for incompatible or different use cases. For example, I don't know, I'm in some kind of application, and now I want to see a 3D model, so I click on the 3D model, and then I download 3D software. But if I'm like already in an augmented reality experience, and I want to have interoperability with another kind of augmented reality, I want to download software, I would expect. So I think that this is not the type of interoperability we're looking for.
But it is kind of a transitional problem. So one of the great things about that iOS had over Android for a while was the iOS revisions were really, really recent because users just updated. There was just a behavior that was linked into being an iOS user. Chrome and Firefox now have that as well. It's got automatic updates. So, you know, the install base is a pretty leading edge thing now that it just happens. I think it's much closer to not responsive design, but adaptive design. So the issues that we deal with mobile, where you have capability detection, it's really just an extension of that. So I think you best to think about it as an extension of mobile web development and capability detection.
I know that it's at the end of our time this afternoon together. I hope you found this to be valuable, and you'll feel free to come up and speak with us afterwards and during the break. Thank you very much.
Thank you. And so the exhibit hall is only open for 25 more minutes. So if anyone wants to go check that out, and then we'll